Hello and welcome back. So we have seen how to calculate the correlation covariance and then how to actually represent it in a heat map, right? And then we understood that correlation only explains the linear relationship. Even though there is non-linear relationship, the correlation coefficient cannot explain that. It is always better you calculate correlation coefficient along with the scattered chart and then understand the relationship and try to make a decision, right? Now we'll see the hypothesis testing way of calculating the correlation coefficient. So in SciPy we have got Pearson R and Spearman R, right? I said there are two ways of the calculating correlation. One is Pearson correlation, second is Spearman correlation. Before we look into Pearson Spearman correlation, let us try to see how to calculate Pearson correlation. In SciPy stats module, we have got Pearson R method, to which we can pass two series objects and then calculate the correlation score. So when you calculate the correlation score with Pearson R method along with correlation score, it will give you a p-value. What is p-value? The probability of being correlated when null hypothesis is true. The probability of experience and salary being correlated when null hypothesis is true. What is null hypothesis? Null hypothesis for correlation Pearson R is that there is no correlation between the experience and salary. When you say there is no correlation between experience and salary as null hypothesis, the p-value should be less than 0.05 to reject the null hypothesis. If you look at the p-value here, it is actually 4.6 into 10 to the power of minus 17, right? Almost 0.7, 7 zeros and then 4. It is definitely less than 0.5. So you can reject the null hypothesis. What is the null hypothesis? There is no correlation between experience and salary, right? So we can reject the null hypothesis and the correlation score is this. So generally correlation score is going to be there, but we just wanted to connect our statistical knowledge with whatever the packages are providing. Okay, so let us now try to understand what is Spearman correlation. Generally, when two columns the scale is similar, you can use Pearson R. What is scale? If suppose that you take two subjects in a school and they conducted a test and both subjects were conducted for 100 marks. The marks are going to be in the range from 1 to 100, right? Or 0 to 100, right? But take another example, right? Two subjects were there. One subject was conducted for 100 marks, the maximum is 100 marks, and the second subject is conducted for only 10 marks. In the first subject, the marks are going to be between 0 and 100. In the second subject, the marks are going to be between 0 and 10. If you want to understand correlation between these two, Spearman correlation is the best because the scales are different. In the first example, the scales are same. Both subjects were conducted for 100 marks. So the marks are going to be between 0 and 100 for the both marks. In that case, you can take Pearson correlation because scale is same. If the scale is different, then definitely you should go for Spearman correlation. What is Spearman correlation? Spearman correlation generally takes the rank of the actual value and then tries to calculate the correlation. So here we have conducted the test for 20 students. One is actually 100 marks, one test for one subject 100 marks and other subject for 10 marks. So we have 20 values for subject 1 and 20 values for subject 2. If you try to calculate rank for these 100 marks and these 100 marks, you will actually get a rank between 0 and 10, right? So then you need to take the correlation between those ranks than the original values. So the rank correlation is nothing but the Spearman rank correlation, and it gives you appropriate relationship than Pearson correlation. Let us try to see. So here the scales are different, right? For subject 1, 100 is the scale, second is 10 is the scale. When I executed that and created the data frame and then tried to do Pearson R, see that it actually gave me 87% correlation, or 0.87, right? It's kind of close to 1, but this is not reliable because the scales are different and we have taken Pearson R. But if you calculate Spearman R for the same two subjects, I've got 92, right? 0.92, right? That means the strength is more, right? When you try to look at subject 1 and subject 2, if somebody is performing well in subject 1, the person is performing well in subject 2 also, because for the same idea we try to collect the subject 1 marks and subject 2 marks. So that strength is clearly evident, or more clearly evident in Spearman R than Pearson R, because the scales are different. It is always suggested that you take a Spearman R. How is it calculated? It actually calculates the rank. For the subject 1 it calculated rank, subject 2 it calculated rank. If you take ranks and then to do Pearson R, the Pearson correlation is also going to be same, right? See this? This is 0.925677 and this is also the same value, right? Spearman R internally what is it doing is calculating the ranks and calculating Pearson R. Spearman R calculating ranks and then calculating the Pearson R. If you look at the slide, you will understand it better. Subject 1, subject 2, so subject 1 and then rank for subject 1, subject 2 and rank for subject 2, and then calculated Pearson R. We have got 0.93. Directly we have used stats, SciPy stats module and passed subject 1 and subject 2. Then also we have got the same value. Internally, the Spearman R is calculating the ranks and then calculating the Pearson R correlation coefficient. That's about the hypothesis way of calculating the correlation coefficient and the importance of p-value and Spearman R. Thank you.